Dr. Ben Newman, and I'm a coronavirus researcher with something like 25 years' experience growing these rotten little viruses. This is meant to be an explainer on what the Omicron variant is and isn't. So here we go. It'll be nice and quick. Um, so what we've got over here are all the variants to date. This is the full SARS-CoV-2 family tree. Look at that. So you got your big blue Delta wedge up here. Look at all those guys. And this little tiny red spot right down here, those little dots, those are the Omicron variant, the sequences that have been pulled up so far. So it's a small branch. It's kind of far away from the normal Delta group. It's a little closer to stuff like Alpha, or this thing called 20D is fairly close, but you haven't heard of that one, I would imagine. And it didn't really go on and do much. So that's what it is. All right. Why do people care? Well, here are the mutations that you get. And this is looking at the entire genome. And you can see here and there a couple little mutations. I marked it for all the nucleotide mutations. Most of these are amino acid mutations also. See all the changes right here? That's the part of the spike that actually makes contact with the human cell. That's the receptor binding domain. And there are 10 different changes here. For comparison, something like the Delta variant has 2 changes in that entire region. So this means that as far as your immune system is concerned, it's like trying to shoot at a target that has no bullseye. You can recognize the rest of the spike, you can recognize any of the other proteins, but it is going to be very difficult to find antibodies that still bind to that one critical site where an antibody will actually prevent infection. So I would expect that this will cause some vaccine resistance and may be a breakthrough in some vaccinated people, but all hope is not lost, for sure. Also, there have been a lot of reports of this virus coming in, particularly from South Africa, that has most of the cases that have so far been sequenced. South Africa has something like 5,000 new cases per day on average, and so far there are only 600 sequences of Omicron in the entire world. It goes up a little bit each day, but that's the perspective. Most most variants of any kind are not being sequenced, so we're not sure if the high apparent percentage of Omicron in Africa is due to selection of which strains are getting sequenced, or if that's actually due to a representative output. There's a test called the S gene dropout, which is like you can do a PCR that looks for 3 different genes and 2 of them will work and the S gene will not work. It'll fail. And that happened for alpha, which has some of the same changes, a deletion right up here. And it also works for Omicron. So that may be how people are picking which ones to sequence and why it seems like there's more of this than there really is, although there's a little bit of it in a lot of places. I think that's important. Okay, so what's going on in terms of actual mutations? So here are all our major lineages that got Greek letters. Here's what's happening with them. Most of them are either on the decline or are effectively extinct now. But you got 21K Omicron doing pretty well out there. It seems to be at least growing. And Delta is just the reigning king, queen, or whatever you like. So if we look at the mutations, actually all the mutations that you see in Omicron have popped up elsewhere before. So all of these in this column are shared with other variants that we know. And some of the other mutations that you see over here in those same 3 regions that are involved in the spike evading immunity or binding to the receptor or getting activated, they've all popped up in at least some of the rare variants. 2 of these, Q493R and T478K, are ones that we reported, thought we discovered here on the Texas A&M campus a while ago, like most of a year ago. But they were on different backgrounds. So these are changes that we know the spike can make and we know can give it some kind of at least temporary advantage in some situation. Doesn't mean, though, that they're guaranteed to be world enders or anything like this. Yeah, definitely not. Okay, how do we know all this stuff about the mutations? Well, here is one test. This is a thing called a surface plasmon resonance test, or a Biocore test if you're into name brands. And the idea here is that you have two phases of the test. One, you measure how well the spike can stick to, like a little chip that's covered in receptors. So we're mimicking the human lung. And you just wash the spike over and it can tumble across, and if it can bind, it'll stay there and the little line will go up. And so you're looking for how fast the line goes up, how high it is when it kind of levels off, because eventually you saturate your surface. So compare the normal receptor binding domain, like the part of the virus that sticks, to receptor binding domain with one change that we find in both alpha and Omicron. So look, that one goes up to about 0.4 and then it tops out. This one goes up, it looks like it's to 0.6 and it hasn't even fully topped out yet. That's a better binder. And then the second half of the experiment is one where you stop putting spike onto the surface and you instead wash it over with nice cooling saline. And so any spikes that are attached can then start to come loose and fall off in the current. And so now we're testing how well does the spike hold on after it sticks on. Because sometimes you get a virus that's good at grabbing and bad at holding, stuff like that. And so we're looking at the fall off here. And if you see something that falls off more slowly, more like that, that would be one that is better at staying stuck to its receptor. And sure enough, N501Y, look at that. Look at that nice curve. So it holds on better and it sticks to it better. And so Omicron has that, but Omicron also has this mutation at 417. And you can see that one is a much lower. It only gets up to about 0.3 at the highest concentration. And then look at that fall off. It just, let's go instantly. So you got a mix of mutations that make it a better binder, a worse binder, and mutations that really don't do anything. Omicron actually has E484 changed to an alanine rather than a lysine, but it's the same position. So because of this is why people say, this is kind of unpredictable. It's a bit of a mixed bag because it's got a little bit of everything in there. And we don't really know how well these mutations are going to work together because it's like a car. It doesn't matter if you take the fastest part or take one part from each of the fastest cars, like get a McLaren race car and take the tailpipe, and get a Lamborghini and take the steering wheel, and get a Ford Focus for like reliability and take the gearbox from that. And then if you connect them all together, you probably don't end up with a working car. That's the thing. Even though each of the parts may be superior, it's a machine. They all have to work together or else they don't work at all. So that's what we're waiting to see, is how well this thing meshes. Some potential cause for concern, or other data, if you like, are from these assembly assays. So we're putting different genes into cells, and we're looking to see how well they come together and make new viruses that can come out and then infect. And so you see a lot of changes here, and they've looked at them. So this is like the normal amount of output, wild type here. And these are changes in the nucleoprotein. So that's going to be inside our little spiky ball up here. I just like that animated image. You can see that most of the changes don't really move the dial much. Tiny bit up, tiny bit down. Yeah, no big deal. But R203M, which is one you get in Delta and Kappa, look at that. It bumps you up to 10 times efficiency. Omicron doesn't have that mutation, but it has this one, R203K, which bumps you up to 3 times maybe efficiency. So it's a little more efficient, but Omicron has to outcompete Delta in order to become a big problem, and it is not clear whether Omicron is going to be able to do that. There's nothing in the sequence so far that is a dead ringer for this thing is going places. Yeah, it's weird. That's about all you can say right now for certain, is that it's kind of weird. So competition. This is a couple of images from a competition paper. This is going to be what determines whether or not Omicron is a problem or just a thing that naturally goes away because it's basically destroyed by Delta. Yeah. Vaccination is likely to have some effect against it, and we will see what the effect is. That remains to be determined. But a booster is probably a good idea because a booster, in addition to raising your antibody levels, gives all your immune system another chance. And so your immune system, every time you get a booster, is going to take its best working T cells and antibody producing cells, and it's going to give them a little extra rope. They can rearrange themselves a little bit. They can make some modifications, and you can end up making an immune system, variant that is actually able to knock out a viral variant that you haven't seen yet. Antibodies just diversify that way, and so do T cell receptors. So there is a pretty reasonable chance that we can vaccinate our way out of this, even if Omicron is somewhat resistant. And it's all about, baseball analogy. It's about staying at the plate and taking a couple more swings. That's what the booster gives you. It gives you a couple more chances at bat. So there you go. And that metaphor may not transfer to any other country, but I like it anyway. So that's the situation with Omicron right now. There are reports coming out that say it's definitely a recombinant. I looked at those reports. It is not. It is not, and the reports are not particularly well done. The way you can demonstrate this to yourself is you just take out that receptor binding domain and search for it, because that's the part where all the changes are, and see if you can find anything that's not Omicron that has all these changes. And the answer is no. There's nothing within 10% amino acid identity of that little chunk that has the most changes. So there's nothing that we know of that Omicron could have recombined with to make these changes. Instead, it just looks like the sort of changes you would expect, except instead of having 2 or 3 mutations per virus, variant, here we've got them all. This is COVID's greatest hits, all on one album. And I don't know. I don't know that they're going to work particularly well, and I don't see anything that suggests this is going to be a particularly aggressive or fast variant. But at the same time, this is probably worth making a variant-specific vaccine, just because the receptor binding site is different enough that we are going to be missing out on some of the antibodies that could protect. And with a booster, a variant-specific booster, we can probably make great antibodies against this one. It's just that it's so different that, once again, making antibodies against this may not protect you against anything else, and antibodies made against anything else may not protect against this. So I'm waiting. I'm hoping for those variant boosters to be ready, and as soon as they are, and as soon as I'm allowed, I'm definitely going to get in line and get mine, and so will everybody in my family, I think. So there you go. That's Omicron in a nutshell. That's what we know, and honestly, most of it is what we don't know. Looking as of yesterday, there are not even any reliable preprints published that have actual biological data in there. The closest we get is one from South Africa that says that there has been slightly more vaccine breakthrough, which is like 1% of their cases, since Omicron rather than before Omicron, but they didn't actually test directly to see whether any of those breakthroughs are from Omicron. And so with that missing piece of the puzzle, there kind of is no puzzle right now, but eventually there will be. So yeah, just watch. This is one to watch, not one to worry about. And I think we're in kind of a Christmas Carol moment right here. Meaning that this is like when, or Muppet Christmas Carol if you prefer, this is like when Scrooge opens up the windows and say, "You boy, what day is this?" and realizes that he has not missed Christmas, that there is still time to make a couple of changes and to fix things. We've got rising cases across Europe. We've got rising cases for the last 5 weeks across the US. We've even got rising cases in Texas, which was hammered on the last wave. And nevertheless, virus is coming. It's almost all Delta everywhere around the world right now, and Delta is very, very vaccinatable. We can stop Delta with the vaccines. The spike has relatively few changes. So this is it. It's time to listen to the ghosts of Christmas past and change this before it happens. Yeah, this is something that we can do. So there you go. Hopefully that does something. Best wishes, happy holidays, and stay away from Omicron. There's nothing good about it, but nothing too scary about it yet anyway. Thanks a lot.